Hello dear students, in this video I'll continue with the 8th chapter, which is linear programming problem. In this video we will learn about the isocost or isoprofit method. In my previous videos I have mentioned that after mathematically formulating a linear programming problem, we have to solve the linear programming problem. That is, solving a linear programming problem is nothing but finding the optimal solution for that particular linear programming problem. Now, to solve this linear programming problem, we have two methods. The first one is the corner point method and the next one is the isoprofit or the isocost method. In the previous videos, we have solved problems based on corner point method. In this video, we will learn how to solve a linear programming problem using isocost or isoprofit method. The meaning of this term iso is nothing but it is same. So here we have isoprofit method is another way to find the optimal solution by using the slope of the objective function line. So what we will do in this isoprofit or isocost method is that we will draw various lines by giving arbitrary values to the objective function z. And we will try to find the optimal solution. If we want to find the maximum profit, then the line with maximum z value will give the maximum profit. And if we want to find the minimum cost, then the line with minimum z value will give the minimum cost. So that is with respect to this isoprofit or isocost method. So if we take isoprofit or isocost line, it is a collection of points which designate solution with same value of the objective function. So as I already mentioned, the meaning of this term iso is same. So if we consider an isoprofit line, then at each point of a given isoprofit line, the value of z will be the same. Or if we consider an isocost line, then on each point on a given line, the value of the cost, that is the objective function z, will remain the same. That is the reason why we have isoprofit or isocost method. Now we will first solve a problem and then we will see the steps in isoprofit or isocost method. So this example question I have taken from the CBSE Handbook. Solve the following linear programming problem graphically. Maximize z is equal to 15x plus 10y subject to 4x plus 6y less than or equal to 360, 3x less than or equal to 180, 5y less than or equal to 200 and x and y greater than or equal to 0. Here what we have to do is, it is already formulated mathematically, so we can proceed with finding the feasible region. So we have to find the feasible region similar to how we do in the corner point method. So let us take a graph sheet and mark the x-axis and the y-axis. So if we consider the first inequality, it is 4x plus 6y less than or equal to 360. We have to draw the line corresponding to the equation 4x plus 6y equal to 360. So if we take when x is 0, this term will be 0. We will get 6y equal to 360. So y will be 360 by 6, it is 60. So when x is 0, y is 60. And next when y is 0. When y is 0, this term will be 0. We will get 4x is equal to 360. In that case, x will be 360 by 4, which is 90. So x will be 90. So to draw the line corresponding to this equation 4x plus 6y equal to 360, we need to have the 2 points. So we can derive these 2 points in this way. Now after seeing these points, let us decide the scale for our graph. So let us take it as 10, 20, 30, 40, 50, 60, 70, 80, 90 on the x-axis. The same scale we have to use on the y-axis also. The first point is 0, 60. X coordinate is 0, y coordinate is 60. So this is the point 0, 60. Then here the next point is 90, 0. This is 90, 0. If we draw a line joining these 2 points, we will get the line corresponding to 4x plus 6y equal to 360. So this is the line corresponding to 4x plus 6y equal to 360. We have the inequality 4x plus 6y less than or equal to 360. So it is this part. So the region corresponding to 4x plus 6y less than or equal to 360. It is this part. We can substitute the coordinates for the origin and check. The coordinates for the origin is 0, 0. When we substitute x as 0, y as 0, 0 is less than or equal to 360. The meaning is that the origin lies in the region corresponding to 4x plus 6y less than or equal to 360. So this is the corresponding region. And next we have the next inequality 3x less than or equal to 180. 3x less than or equal to 180, it is, if you want to draw the line corresponding to this inequality, we have 3x equal to 180 or x is equal to 60. So we have to find the region corresponding to x less than or equal to 60. Now x is equal to 60. It is a straight line which is parallel to the y-axis and passes through 60, 0. This is 60, 0. So if we draw a straight line parallel to the y-axis and passes through 60, 0, we get the line corresponding to x is equal to 60. We need the region corresponding to x less than or equal to 60. Again, if we substitute the origin, x as 0, 0 is less than or equal to 60. The meaning is that the origin lies in this inequality. So this is the line corresponding to 3x less than or equal to 180 and the region is this part. Next we have the next inequality 5y less than or equal to 200. So if we want to draw the line 5y equal to 200, y will be 200 divided by 5, which is 40. So we have to find the region corresponding to y less than or equal to 40. Now this line y equal to 40, it is a straight line which passes through 0, 40 and parallel to the x-axis. Here we have got only the y-intercept. So here it is a line which passes through 0, 40. This is 0, 40 and it is parallel to the x-axis. So this is the line 5y equal to 200. The region corresponding to 5y less than or equal to 200 is this part. Because if we substitute the origin 0, 0 and check, origin lies in the region corresponding to 5y less than or equal to 200. So it is this part. And next we have the non-negative constraints, which is x greater than or equal to 0 and y greater than or equal to 0. It is nothing but it is the first quadrant. So the region which is common to all these, it is this part. So this is the feasible region. So up to this step, the corner point method and the isocost or isoprofit method is the same. That is, we have to find the feasible region and we have to note down the corner points. So these are the corner points. Again, the theorem for corner point method also holds. The maximum or the minimum value of z will occur at one of the corner points if it has a solution and if the feasible region is bounded. So here the feasible region is bounded. So maximum value of z will occur at one of the corner points. So we know the coordinates for this corner point. It is 60, 0. For this we can find, and for this one also we can find. So let us mark the corner points A, B, C and D. So these are the 5 corner points O, A, B, C and D. Now let us find the corner point only that will maximize the objective function z. If our objective is to maximize z, then in that case this z, it is a profit function and the lines that we are going to draw will be the isoprofit lines. So how we can draw these lines is that we have to give an arbitrary value for z. Now how we can find this value? We have to take the LCM of the coefficients of x and y. So here the coefficients of x and y are 15 and 10. So LCM of 15 and 10, it is 30. LCM of 15 and 10 is 30. What we can do is, if our scale is more, then we can take any multiple of this LCM. So for simplicity's sake, I am taking 150. The value of z as 150. So I am taking 15x plus 10y equal to 150. And I'm going to draw the first isoprofit line. So this is my first isoprofit line where the objective function, the value for the objective function is 150. Again, it is the same way in which we have to draw this line. So when we put x as 0, this term will become 0, 10y equal to 150, so y is 15. And when we take y as 0, this term will be 0, 15x equal to 150, so x will be 10. Now we have to draw a line joining the points 0, 15 and 10, 0. So 0, 15, it is somewhere here. So this is 0, 15 and this is 10, 0. And now we can draw a line joining these 2 points 0, 15 and 10, 0 to obtain the line corresponding to 15x plus 10y equal to 150. So this is the line 15x plus 10y equal to 150. If we take any points on this line, the coordinates x and y, if we substitute the coordinates for x and y, we will get the value of z as equal to 150. So each of the point in this line will have the same value for z, which is 150. That is the reason why we call this line as an isoprofit line. Now what we have to do is, we have to draw lines parallel to this line which is passing through each of the corner points. So if we consider this line which is parallel to the line which we just now drew, here the value of z is equal to 0. Like this we have to proceed drawing lines parallel to this line until we reach the line which is farthest from the origin. That is, we reach a line which is very far from the origin and it is passing through at least one corner point of the feasible region. Now this point will give maximum value of z. If we find the coordinates for this point and substitute it for x and y, we will get the maximum value of z. So here the coordinates for B, we can find it very easily. We already know the x coordinate is 60. So if we substitute x as 60 here, we will get the y coordinate as 20. So here 4x plus 6y equal to 360. We know the x coordinate it is 60. So 4 into 60 plus 6y is 360. So 6y will be 360 minus 240, it is 120. So y is 20. So here the coordinates for B, it is 60, 20. So this corner point B will maximize Z. The coordinates x is equal to 60 and y equal to B of corner point B satisfy the given constraint, and the total profit obtained is Z is equal to 15 into 60 plus 10 into 20. So it is 900 plus 200, which is 1100. So this is how we have to go about if we have to solve the linear programming problem using isoprofit or isocost method. Now let us see the steps. What all we have done? All these are given as steps here. Now it will be easy to understand the steps. The first step is formulate the given LPP in mathematical form. The question which we just now saw, it was already formulated. The next step is identify the feasible region and extreme or corner points of the feasible region. So this is the next step. This is the same that we usually do in corner point method also. The third step is give some convenient values to Z and draw the line so obtained in the XY plane. So we gave the value 150 to Z and we obtained the line 15x plus 10y equal to 150 here. The next step is, if the objective function is to be maximized, then draw lines parallel to the line in step 3. So we have to draw lines which is parallel to the line that we drew in step 3. The next step is obtain a line which is farthest from the origin and has at least one point common to the feasible region. So we have to draw lines parallel to this line until we obtain a line which is farthest from the origin and it has at least one common point in the feasible region. The last step is find the coordinate of the common point obtained in step 4. I'm sorry, this is step 5. The point so obtained determine the optimal solution and the value of the objective function at these points give the optimal value. So this is what we have done. We have to find the coordinates for this point and then we found the value for Z. So these are the steps involved in a maximization problem. In a maximization problem, we have to draw lines parallel to the line for which we have taken an arbitrary value of Z and we have to find the line which is farthest from the origin. Now we can use this isocost or isoprofit method only when the slope of the isocost or isoprofit lines are negative. Slope is negative means the line should be of this type. If the line is of this type, then the slope is positive. So here we can see that the slope is negative. Now let us move on to another problem where we have to find the minimum value of the objective function Z. Solve the following linear programming problem graphically. Minimize Z is equal to 18x plus 10y subject to 4x plus y greater than or equal to 20, 2x plus 3y greater than or equal to 30 and x and y greater than or equal to 0. So in the previous case, we saw maximization problem where we drew isoprofit lines and we took the line which is farthest from the origin. In minimization case, we have to draw isocost lines and we have to find the line which is nearest to the origin. That is the only difference. So let us solve this problem. So this problem is already mathematically formulated. We have to find the feasible region. So here we have two constraints, 4x plus y greater than or equal to 20 and 2x plus 3y greater than or equal to 30. So first let us take the first inequality and find the line corresponding to this equation. 4x plus y equal to 20. When x is 0, this term becomes 0. So y will be equal to 20. The next case, when we take y as 0, then this term will be 0. 4x will be equal to 20. So x will be 20 by 4, which is 5. So to draw this line 4x plus y equal to 20, we need 2 points. The 2 points we have obtained are 0, 20 and 5, 0. So let us have the graph. So here let us take the scale as 1 centimeter equal to 5 units. 5, 10, 15, 20, 25. This is the x-axis and this is the y-axis. Here again the same scale. So we have 0, 20 here and 5, 0 here. Let us draw the line joining these 2 points to get this equation to find the region corresponding to this inequality 4x plus y greater than or equal to 20. If we consider the origin, the coordinates of the origin is 0, 0. If we substitute x as 0, y as 0, 0 is not more than 20, it is less than 20. So the origin, it does not lie in the region corresponding to this inequality. So it is the other side. So this is the region corresponding to 4x plus y greater than or equal to 20. The next inequality is 2x plus 3y greater than or equal to 30. First let us draw the line corresponding to 2x plus 3y equal to 30. So 2x plus 3y equal to 30. Here when x is 0, this part will be 0. We will have 3y equal to 30. In that case y is 10. And when y is 0, this part will be 0. We will have 2x equal to 30. In that case x will be 15. So the 2 points are 0, 10 and 15, 0. So this is 0, 10 and this is 15, 0. Let us draw a line joining these 2 points to get this equation 2x plus 3y equal to 30. Now to find the region corresponding to 2x plus 3y greater than or equal to 30, again if we substitute the origin and check, origin it does not lie in this region. So it is the other side of the line. It is this part. It is 2x plus 3y greater than or equal to 30. So the region which is common to, next we have the non-negative constraints, x greater than or equal to 0 and y greater than or equal to 0 is the first quadrant. So the region which is common to all these inequalities, it is this part. It is this part. And now we have to identify the corner points. Let us mark this as A. This is the corner point A. This is B and this is C. Now we know the corner point A, it is 15, 0 and corner point C, it is 0, 20. Now if you want to find the coordinates for B, if we draw it on a graph sheet, we may get the coordinates for B directly. Even otherwise, B is the point of intersection of these two lines. So if we solve these two equations, we will be able to get the coordinates for B. So the equation of this line is 4x plus y equal to 20, and the equation of this line, it is 2x plus 3y equal to 30. So if we take this as 1 and this as 2, so if we have the first equation minus 2 times the second equation, 4x plus 6y equal to 60. So we get minus 5y equal to minus 40, or y is equal to 8. So when y is 8, when we substitute y equal to 8 in the first equation, we get 4x plus 8 equal to 20, or 4x is equal to 12, x is 3. So the coordinates for B is 3, 8. So this is the coordinates for B. And now we have found the coordinates for each of these corner points. The next step is we have to solve this linear programming problem using isocost or isoprofit method. So here in this case we have minimize z is equal to 18x plus 10y. So here the lines that we are going to draw, they are called the isocost lines. Now to draw these lines, we have to take an arbitrary value of z and have a starting line. To give an arbitrary value for this z, we have to take the LCM of 18 and 10. That is, we have to take the LCM of the coefficients of x and y. So now the LCM of 18 and 10. So if you find the LCM of 18 and 10, it is 90. And now we can give the arbitrary value for z as the LCM directly for simplicity's sake, or we can give a multiple of this 90. So I am taking the first isocost line as 18x plus 10y equal to this LCM 90 into 3, which is 270. So let us draw the line corresponding to 18x plus 10y equal to 270. That is the first isocost line. So when x is 0, when this part is 0, we will have 10y equal to 270, or y will be equal to 270 by 10, which is 27. And then for the next point, let us take y as 0. If we take y as 0, we will have this term 0, then 18x equal to 270. So x will be 270 upon 18, which is 15. So we have the 2 points 0, 27 and 15, 0. So 0, 27, it is here. This is 0, 27, and 15, 0 is this point. This is 15, 0. So if we draw a line joining these 2 points, we will get the equation corresponding to 18x plus 10y equal to 270. So this is a line corresponding to 18x plus 10y equal to 270. Now if we take any point on this line, the coordinates will satisfy this equation. The coordinate on any point on this line, the value of x and y, when substituted in this equation, will give the value as 270. So that is the meaning of isocost line. That is, the cost will be the same on each point of this line. Now we have to draw lines parallel to this line so that we will be able to find the optimal value of the objective function z. Now here we have to find the minimum value of z. So we have to draw lines parallel to this line which is closer to the origin. So let us draw another line which is parallel to the first line that we just now draw and passing through each of the corner point. Let us draw the next line. And now if we see of all these lines, this is the line which passes through this corner point B and it is closest to the origin. That is, it is closest to the line z is equal to 0. So this is the line z is equal to 0. So it is this line which is closest to the origin and it passes through the point B which is 3, 8. So the corner point B will minimize z. B 3, 8 minimizes z. Now if we want to be sure about this, here we can see that the feasible region is unbounded. If the feasible region is unbounded, we have to find the value of z at this corner point B. So the value of z at this corner point B is z is equal to 18 into 3 plus 10 into 8. So we have z as 18x plus 10y. We get the corner point B minimizes z using this isocost line. So we have to put x as 3 and y as 8 in this equation and we have to find the value of z. So this is 54 plus 80, it is 134. Z is equal to 134. And now here we can see that the feasible region is unbounded. So to be sure whether B 3, 8 whether it minimizes z, we have to check whether this given linear programming problem has a unique solution or not. And now to check whether the optimal value of z is 134 or not, we have to draw the half plane corresponding to 18x plus 10y less than or equal to 134. If this half plane corresponding to 18x plus 10y less than or equal to 134, if it crosses the feasible region, then the given linear programming problem has no solution. On the other hand, if this region, if it passes through a single point B, then we have that particular point, it optimizes z or it minimizes z. So to find this region, let us draw the line corresponding to 18x plus 10y equal to 134. So when x is 0, this term will be 0. We will have 10y equal to 134 or y will be 134 divided by 10. It is 13.4. And then when y is 0, this term will be 0. X will be 134 upon 18. It is approximately 7.4. So let us mark the points 0, 13.4. It is somewhere here. And 7.4, 0. It is somewhere here. So if we draw a line joining these 2 points, so this is the line corresponding to 18x plus 10y equal to 134. So the region corresponding to 18x plus 10y less than or equal to 134, it is this part. So this is the region corresponding to 18x plus 10y less than or equal to 134. Now this region, it does not cross the feasible region. As a result, the corner point B 3, 8, it minimizes z and the optimal solution is x is equal to 3 and y is equal to 8. So here we have the result. The coordinates x is equal to 3 and y equal to 8 of corner point B satisfy the given constraints and the minimum value of z obtained is z is equal to 134. So this is the result. All these can be done in the rough. It is important that we need to have the graph and the result as far as isocost isoprofit lines are concerned. So this is the isocost method where our objective is to minimize z. Now let us see the steps. The first step in case of a minimization problem is we have to formulate the given linear programming problem in the mathematical form. So in the example which we just now saw, it is already formulated in the mathematical form. Then the next step is we have to identify the feasible region and the extreme corner points of the feasible region. That is the next step. The third step is we have to give some convenient values to z and draw the line so obtained in the xy plane. So if we have z as ax plus by, it is easy if we give the value of z as LCM of a comma b, that is the coefficient of x and coefficient of y, or we can give a multiple of the LCM of a comma b based on the scale that we take. The next step is if the objective function is to be minimized, then draw lines parallel to the line in step 3 and obtain a line which is nearest to the origin and has at least one point common to the feasible region. So if the objective function is to be minimized, we have to draw lines that is parallel to the line that we drew in step 3, that is the isocos line which we have already drawn, and we have to obtain the line which is nearest to the origin and has at least one point common to the feasible region. And then the last step is we have to find the coordinate of the common point that is obtained in this step, and the point so obtained, it will determine the optimal solution, and the value of objective function at these points will give the optimal value of z. It will give the optimal value of z. So it is similar to maximization problem. In maximization problem, we have to draw lines parallel to the line in step 3 and we have to obtain a line which is farthest to the origin. But in minimization problem, we have to obtain the line which is nearest to the origin. So these are the steps involved in isoprofit or isocost method. And now in these problems that we saw, we can see that the slope of the isocost or isoprofit lines, it is negative. That is, it is like this. So if we have lines of this type, then we say that the slope of the line is negative. In all these cases, we saw the slope of the line negative. I hope this video was useful for you. In my next video, I'll solve the questions from CBSE Handbook exercise which is on isocost or isoprofit method. If you have not subscribed to my channel, please subscribe. Thank you for watching.